Hello students, we're going to continue our discussion of Chapter 8, Hypothesis Testing. We're talking about the level of significance, alpha. It's also called the chance of error. So some questions will state that level of significance is 5%. Just remember that that's just another way of saying alpha value or the chance of error. Sometimes also called the level of risk, and this gets into understanding the previous example we talked about, this one, where there's 65, where it's assumed that 65% of all registered voters would vote for candidate A. We saw that when the sample size was 100, that our decision was that we should not reject the null hypotheses. When the sample size grew to 500, we noticed that our decision changed to reject the null hypotheses. And it's because of that potential change with our sample data, that's why we are going to refrain from making any statement to accept the null hypotheses or to state that the null hypothesis is good. Which gets into this level of significance and the two possible errors. So two types of errors: type 1 error, type 2 error. Testing purposes, this is going to be on the test in terms of some multiple choice type questions. It's probably advisable to remember one type because the other type is just exactly the opposite. So a type 1 error is when you reject a true null hypothesis statement. So you are rejecting it when it's really true. Of course, you shouldn't do that, hence it's an error. It's a type 1 error which is controlled by the level of risk or the level of significance or the chance of error alpha value. Generally at about 5%, sometimes down to even, or ranging from 10% to 1% kind of thing as our type of error. That's basically stating the chance of making that type 1 error. A type 2 error, denoted as beta, is the opposite of a type 1 error. So we are not rejecting when we actually should. So the null hypothesis statement is wrong, but we have failed to reject it. We have not rejected it. Hence, we have made a mistake. So those two types of conflicting errors. So of course, if you really decrease the risk of making a type 1 error, you're going to increase the risk of making a type 2 error. And we could look at some examples of that. So here's a little chart about the level of significance. The null hypotheses condition over here. The null hypothesis is true or it's false. The decision, so when it's true and we are not rejecting it, basically we have made a correct decision. When it's false and we actually reject it, we are also then making a correct decision. The two types of errors right here. Type 1, we reject it when it's actually true. Type 2, we fail to reject it. We did not reject it when we actually should have. So in practice, the researcher states a level of type 1 error, their level of risk that they're willing to undertake to make that type 1 error. That's alpha. That's always given as part of the question. And we try to minimize or at least mitigate the risk of a type 2 error by making this statement: do not reject the null hypotheses, instead of saying to accept the null hypotheses or to state that the null hypothesis is good. Once again, we're not going to make those statements. We don't make those statements, we're not actually making a type 2 error if we just say do not reject the null hypotheses. That's like someone in a court of law basically saying, you're either guilty or you're not guilty. Why doesn't the judge say you're innocent? Generally with the belief that if you are in a court of law, there must be some reason why you're there. There's a little bit of guilt. So that's why, judges, court of law generally don't say you're innocent, which is basically saying, you are good. Basically, they're saying that you're not guilty with the assumption that if we had more evidence, if we had found all the evidence, we would probably conclude that you are guilty of something. So let's look at a couple examples. What's a type 1 error or type 2 error in each of these situations? We're going to look at this first one, the eye exam, to determine if a pilot or a person is visually qualified to be a pilot. Let's go on to a whiteboard to draw this out. List out the different types of errors that we could make. Okay, so the eye exam example. The triple E, eye exam example. The null hypothesis is the belief that you have good eyes. The doctor basically saying that your eyes are sufficient for what you need them for being a pilot. The alternate hypothesis, something that the doctor is trying to prove, is you don't have good eyes. So good eyes basically meaning you're qualified to be a pilot. So let's look at the different types of error. The type 1 error. So remember that a type 1 error is you are rejecting a true alternate hypotheses. So you are rejecting, let's just write that in here. Rejecting the null hypotheses when it's true. So type 1 error would basically be that you have good eyes, but for whatever reason you fail the test. Good eyes, but fails the test. Not a really nice outcome. Your eyes, you've treated your eyes really well, and you go for that test because you want to be a pilot. And the doctor says, sorry, not good. So type 2 error, of course, you are not rejecting it when you actually should. Basically, the result here would be that you pass a test when you have bad eyes. You pass a test, but you actually do have bad eyes. So however that works out, maybe you went and read the chart, memorized that eye chart beforehand, so you can pass, or the doctor just makes a mistake. What are the consequences? Let's write that up here. And which type of error are you more likely to want to control? So what's the error when you make a type 1 error? What's a consequence when you make a type 1 error? The consequence is basically you don't get the job. You don't get to be that pilot. Hopefully you go get a second opinion. But that is the immediate consequences. You don't get the job. You fail that eye exam. Consequence for a type 2 error is basically you have a pilot. You get someone who gets a job to be the pilot with really bad eyes. So a pilot with bad eyes, maybe legally blind, is actually flying the airplane. The big question is, which type of error do you want really controlled? Of course, you want to control a type 2 error in this case. Is type 2 error is, what should we say here? Just say something to be controlled, rather than a type 1 error. If you send a few people away who have good eyes, good eyesight, but you fail them for whatever reason, they don't get the job, well, there's always something else they can do, unfortunately, or fortunately. They don't get that. Unfortunately, they don't get to be a pilot, but it's still protecting the industry. If you make a type 2 error, you're letting people fly a plane that really shouldn't fly a plane. So definitely type 2 error is something that you want to control. Let's see here. So basically we would specify a type 1 error, maybe 5% level. Type 2 error, we are not going to say, the doctor's not going to say you have good eyes. The doctor would say for a type 2 error is something like this. You didn't fail the test. Or something like, based on our exam, we don't have any evidence saying that your eyes are bad. It's up to the person reviewing the results or someone in the airline industry to actually say, well, I guess if you didn't fail a test, your eyes are good. So it's up to them to make that decision. The doctor is protecting his or her assets here and liabilities by making a statement like this. You didn't fail the test. Your eyes, I guess, are not bad. I'm not going to say they're good, because if I'm wrong, if I had better testing equipment, or if other factors came in play, that that result could change. So that's what we mean by type 1 and type 2 error. There's some other examples you can go through. I've gone through those in the course package as well. The next slides get into back to hypothesis testing in terms of a slightly different format to look at, or to review some hypothesis testing. So we'll come back to this in the last video for this chapter.